Good morning, Year 5. So today I'm going to show you a flipped classroom video on pulleys and levers. So it's going to be our science topic for autumn 2. And I think it's important that we learn the vocabulary that's expected in your work. So we'll find out what the definitions of vocabulary means. So gravity. So gravity is a very important vocabulary word for our topic. So gravity means the force of attraction between any two bodies with mass. So we see the effect of gravity when we drop, for example, a pencil onto the table, whatever that may be. The force of gravity is pulling the object down, just like we can see with the tennis and the basketball. When it's dropped, gravity pulls the object down. It's a force of attraction, so it means it goes towards it between any two bodies with mass. So with our basketball, the basketball has mass and the earth has mass, and they've attracted, so the basketball has fallen because it's been let go by a student. They've attracted together. Air resistance. So air resistance, also known as drag, is the forces that are in opposition to the relative motion of an object as it passes through the air. So motion just means when it's moving. And as we can see with this parachuter, is moving downwards. That's the motion of it. Now, air resistance, if the motion is going downwards because the parachute is falling downwards because of our previous vocab word, why is he falling down? What's the bottom arrow? Because of gravity. Yes, correct. So because of gravity, the force in opposite to that is called air resistance, as we can see working against gravity, which is forcing the parachute to stay open, which reduces the speed that they fall down. If there was no oppositional force, so if there was no air resistance, it was only gravity, the skydiver would fall flat on his face straight away. But because there's opposition, that's why it reduces the motion of an object as it passes through the air. Any object, it's not just parachuters, but any object that is dropped or is falling is facing air resistance. Next one, friction. So friction is the force that opposes the motion of two surfaces in contact with each other. So here we can see someone pushing a box. Now, the pushing force, the motion, is going forward because the motion of it is the direction it's traveling in. So the motion is still going forward. However, the force that's working in opposition to that is called friction. Now, some areas might have more friction than others. If you pushed a box on a carpet, it would move slower than if you pushed a box on an ice rink. Why do you think that is? It's because an ice rink would have less friction than a carpet. Yeah. Balancing force. Yes. So balancing force is a force that is equal in magnitude but opposite in direction to another force. So for example, a book on a table is an example of balancing force. The weight of the book is perfectly balanced by the reaction force of the table. If it was not balanced, that book will go straight through the table, but it's not. Because the book is resting on the table, because the weight of the book is equally balanced to the reaction force of the table, it remains on top of the table. It's an example of a balanced force. Have a look around the room you're in. Can you see any other balanced forces? I'm sure you can. Our next one, weight. So weight is something you might be familiar with, but we need to understand the scientific definition of it. So weight is a measure of the size of the pull of gravity on an object. That sounds very wordy, but it's how we should define it in science. So we can see the weight of this apple is measured in newtons, because weight is measured in science in newtons. So we can see this apple is 1 Newton worth. We can use this Newton measure to measure the weight. So you may see these in class in the future, springy thingies, as some teachers like to call them, but they're actually called Newton meters. And they tell us, what do they tell us? The weight of an object, correct. And finally, mass. Now, mass is quite similar to weight, but there's a crucial difference. Mass is a measure of how much matter there is in an object. Now, mass would not change, but weight does change depending on where you are. So if you're in space, your weight would be different because of the different gravitational pull, the different forces at work, but mass would always stay the same. Mass is also measured in kilograms, so that's an easy way of remembering it. So if weight is measured in newtons, mass is measured in kilograms. And that's our vocabulary so far. Hope you enjoyed. Look forward to seeing you in class.